This time I'm going to be talking through one of those classic think of a number sequences that you might do when you're introducing algebra to a class, and it always seems to amaze the pupils at the end when they all get the same answer. So have a quick run through the instructions on your screen now, make sure you always get an answer of 1, and then have a think how you might use algebra tiles to model this. So this idea of think of a number is nothing new, it's been around forever, but I find using algebra tiles strengthens that reasoning as to why we all end up with the same number. So obviously you start by getting them all to pick a random number themselves, and inevitably 80% of the class will all end up at the same number, and there'll be 20% or so that have messed up the arithmetic somewhere. So then you might want to try a numerical example where we all start with the same number. So say we all start with 10 and work through this just to make sure that pupils can follow every single step. So think of a number, add 4 to it, double your answer, it's going to give you 28. Subtract 6, 22, halve your answer, 11, and then subtract the 10 that you started with, gives you that answer of 1. So you've got to make sure, this is like the prerequisites if you like, you've got to make sure that pupils can get to this answer of 1 using numbers. And then we introduce the algebra tiles. Okay, so all the pupils now have a set of algebra tiles in front of them, and we're now going to work through the sequence again, but this time using the generalised case where we don't know this number, so we're calling it x. So get every pupil to bring in an x tile. Now we're going to add 4 to this number. Now some pupils might want to bring in 4 more x's here, so you can have that discussion that we're not bringing in 4 x's, we're bringing in 4 units here. So let's bring in 4 of the yellow tiles, and this expression here is x plus 4. Now what's the next instruction? We're asked to double our answer. So if we've got x plus 4, if we double that, we're going to end up with another x. And when we double the 4, we're going to end up with 8. And at each step, pause and get the pupils to say exactly what expression they've got in front of them. So now I've got 2x plus 8. Now we're going to subtract 6 from our answer. Now if you're doing this properly, we'd actually be adding in negative 6 here, and then 0 pairing these off. It's very tempting just to take away 6 here, but if we're going to do it properly, we'll add in negative 6, and then we'll 0 pair that off to leave us with 2x plus 2. And now we're asked to halve our answer. Again, so multiply by a half or divide by 2. Either way, we're going to end up with x plus 1. And then finally, we subtract the number that you first thought of. Now, because pupils brought in this x tile to begin with, a lot of them now will be okay with, okay, I need to subtract this x tile here. Again, if we're doing it absolutely properly, strictly properly, we should bring in a negative x tile to 0 pair that off. So after the final instruction, we're just left with this 1 yellow unit tile here. So we're always going to left with 1. So I've found that using the algebra tiles to model this really helps make pupils make sense of the process of why we always end up with 1. And then you can get students to create their own think of a number problems. So what I often do now is get them to work in pairs and generate their own think of a number problems and try and set their own target number. So ask them what their favourite number is or something. Can you get to an answer of 20 or of 5? And you can reduce or increase the number of steps depending on how the pupils are getting on. So like a really obvious case is to start off with think of a number, double it, and then halve it, and you get the number that you first started with. Or think of a number, add 2, and then subtract 2, and you get the number you first start off. So it's really easy cases, just that idea of inverse operations, and then start building up the steps as the pupils get more confident.